I'll be discussing on microbial growth. This is part of the chapter 1 of Mayhon. So first, what are the three major needs for growth, particularly of bacteria? So note a bacteria needs carbon. 50% of it is carbon. It needs nitrogen, 14%, and source of energy would be adenosine triphosphate or triphosphate. Small amount of molecules are phosphate for nucleic acid, phospholipids for the cell membrane, and sulfur for the protein synthesis. A bacteria, or we'll be discussing about the nutritional requirements for growth of a bacteria. So first, we need to discuss about where does the carbon, where does the bacteria get the carbon? Okay, the 50% of the carbon. So a bacteria can be an autotrophs or lytotrophs when the bacteria would use a carbon dioxide as a sole source of carbon, addition with the water and inorganic salt. So it would also obtain energy by photosynthesis or phototrophs, or oxidation of the inorganic compounds, which is your chemolithotrophs. Okay? A bacteria would require more substance as a source of carbon. It is known as heterotrophs. So if the substance or the carbon source is coming from an organic source, okay, example is glucose, and energy is coming from oxidizing or fermenting organic substances, okay, this is known as heterotrophs. Note, almost all the bacteria in the human body are heterotrophs. Example of the bacteria inside the body are Escherichia coli, and then Pseudomonas aeruginosa. Next, we need to know about the environmental factors affecting the growth of a bacteria. First is pH. pH is the pH wherein organism is best grown is a neutral pH. So the neutral pH, or sa katawan ng tao, a human body has 735 to 745. So yan yung normal pH inside the body. So most of the pathogenic organism would grow between this 7.35 to 7.45 kung pathogenic yung bacteria. So note, inside the laboratory, we do culture, and the culture is known as the agar, or yung pinapakain natin dun sa bacteria, is known as media. Okay? So, the pH of the media needs to be in a neutral form. It needs to be in 7 to 7.5. Okay? So, hindi pwedeng acidic, hindi rin pwedeng basic. Pero may mga bacteria na mas nag-grow sa acidic environment, may mga bacteria na nag-grow sa basic environment. So, what are the classification of bacteria based on the pH? If the organism would grow at the pH of 6.5 to 7.5, it is known as neutrophile. What are the neutrophiles? Yung mga organism inside the body. Example, your Escherichia coli is a neutrophile. Your Staphylococcus aureus is neutrophile. So, commonly, yung mga normal flora natin, okay, are neutrophiles. Next would be acidophiles. Acidophiles are best in acidic habitat. So, it's actually less than 6.5. So, some example of this is your Helicobacter pylori. So, Helicobacter pylori, it actually causes peptic ulcer. So, as we actually know, the stomach can actually have an acidic environment of pH of 1. Okay, this bacteria, Helicobacter pylori, can resist the pH of 1. Okay, so yun. Next would be alkalinophiles. Alkalinophiles lives in your alkaline soils and water which has a pH of 11.5. Okay? Some of the examples of this is your organism which is your Vibrio cholerae, yung organism na nagkakos ng cholera. Next, we need to discuss about temperature. Temperature actually influence also the growth of bacteria. Sometimes, kapag sobrang init, pwede naman din silang mamatay. So, first would be your psychrophiles. Psychrophiles is the bacteria grow best in a cold temperature. So, a bacteria having a 10 to 20 degrees Celsius, ibig sabihin nagbubuhay sila sa 10 to 20 degrees Celsius is a psychrophile. Next, an organism that can actually grow on 20 to 40 degrees Celsius, it is known as mesophile. So, nasa gitna sila. So, most of the organism inside the body are mesophiles because our body has a 37 degree Celsius. So, more or less 35 to 37 degrees Celsius. Next would be thermophiles. These are your extremes. Okay, these are the extremes. Bacteria that actually grow at a high temperature. Some example of this are yung mga nakikita natin sa crater ng volcano, sa hot spring, because it can actually resist the temperature because it can grow at 50 to 60 degrees Celsius. Some of the organisms are Bacillus stearothermophilus. Thermophilus. Okay. Philus. So, just some of the examples of your thermophiles. For the psychrophiles, some examples are your Yersinia pestis. It can actually still grow even in a cold temperature. Next is the atmospheric requirement for growth. Okay? Note, may mga organisms na nag-grow even with or without oxygen or nag-grow lang with oxygen. So, some example of an organism that is obligate aerobes, meaning they need oxygen for growth, are your Brucella, Bordetella, Microbacteria, and Pseudomonas. There are reasons why it actually can penetrate or can actually resist oxygen because of some enzymes that it actually produce. So, i-discuss ko yan mamaya. So, next. Okay, next is your aerotolerant anaerobes or facultative, or before it is known as facultative aerobes. So, note it can survive with the presence of oxygen, but do not use oxygen in the metabolism. So, ibig sabihin nun, without oxygen, yes, it can actually grow. Without oxygen, makakagrow pa rin sila. Some example of this is Clostridium species and Propionibacterium. Okay? Next would be your obligate anaerobes. It cannot grow in the presence of oxygen. So, some example of this are your anaerobes. These are your Bacteroides fasciculis. So, ibig sabihin, kapag nagkaroon ng oxygen, namamatay sila. Next would be facultative anaerobes. So, this can grow either with or without oxygen, similar to facultative aerobes or aerotolerant. Pero dito, note, with or without, okay lang. They can actually use also oxygen for metabolism purpose. One example of this is your Escherichia coli or the Enterobacteriaceae, under the Enterobacteriaceae. Okay, next would be capnophilic. Nung kanina, we actually discussed about oxygen. Now we'll be discussing about carbon dioxide. So, grow best when the atmosphere is enriched with carbon dioxide. So, commonly, it is a 5% to 10% carbon dioxide. So, a capnophilic, inside the laboratory, we actually do, okay, we actually do candle jar method. Ang candle jar is yung maglalagay lang kami ng candle sa loob ng jar. Okay, candle jar method. Paano namin na-obtain inside the laboratory yung 5% to 10%, okay, carbon dioxide, we use candle jar. Okay, candle jar. So, ang gagawin natin, we'll lit an unscented candle with unscented candle, tapos meron tayong petri dish. Ito yung jar. Pwede kayong magano sa isang Nescafe na, yung dati mga malalaking mga jar. Okay? Tapos lalagyan lang natin ng candle. So, sorry sa drawing, pero candle to. Okay? And then, tatakpan natin. So, once na namatay, okay? Once na namatay yung ilaw, di ba nag-i-emit siya ng black na smoke? Okay? Once na nag-emit siya ng black na smoke, that is your carbon dioxide. It emits approximately 5% to 10% carbon dioxide. Sino-sino ang mga organisms na capnophilic? It is your Haemophilus influenzae and your Streptococcus pneumoniae. So note, kung mapapansin nyo, yung may mga capnophilic, that are organisms na may capsule. Okay? That are organisms na may capsule. Next is microaerophilic. So, micro means konti, aero means oxygen. So, it needs a reduced amount of oxygen for growth. So, it does not need a lot of oxygen. Dati kasi, they are actually telling it as aerotolerant, pero it's actually stated that it is a microaerophilic because it needs a reduced amount of oxygen. So, one example of this is your Campylobacter species. So, it needs 5% to 6%. Okay? 5% to 6% oxygen. Okay? How does the bacteria, especially obligate aerobes and facultative anaerobe, can tolerate oxygen? So, paano nga ba nila matotolerate ang oxygen? So, if the organism would actually have, example, yung mga facultative anaerobes saka obligate anaerobes would be exposed to oxygen, kailangan nila ng dalawang enzyme. Ano yung dalawang enzyme na yun? It is your superoxide dismutase and your catalase. Okay? So, kapag una, yung oxygen, okay? Yung oxygen, using your superoxide, okay? Superoxide, nagiging peroxide na lang. Okay? Nagiging peroxide na lang yung oxygen. Nagiging peroxide na lang siya. Okay? So, with the presence of hydrogen, it would become hydrogen peroxide. Okay? The bacteria would actually have also a peroxidase to convert it into water. Okay? Or sometimes it has the catalase to actually have the hydrogen peroxide. Okay? Para yung hydrogen peroxide maging water. Okay? Para yung hydrogen peroxide ma-metabolize na to water. So, the two important enzyme, okay, to survive ang facultative anaerobes saka obligate aerobes are the catalase and then yung superoxide dismutase. Okay. So, inside the laboratory, we can actually assess, okay, atmospheric growth, okay, by using thioglycolate. By using using thioglycolate. Thio or thioglycolate broth. Okay? This is an example of thioglycolate broth. If you expose the thioglycolate broth into oxygen, if it is obligate aerobes, the turbidity can be found at the topmost or the surface of the tube. If the organism is an obligate anaerobe, you can actually see the organism or the turbidity below. So, ibig sabihin, hindi siya nangangailangan ng oxygen para magkaroon ng growth. Another, if it is facultative anaerobes, you can actually see it at the surface and then at the bottom. So, it has a wide or a spreading growth. While if it is aerotolerant, so you can actually see it spread in the entire thioglycolate broth. Okay. Next, we need to discuss about bacterial growth. So, a bacteria replicates using binary fission. Okay? So, hindi lahat ng bacteria, okay, note, hindi lahat ng bacteria nagre-replicate agad. Okay? There are some bacteria na within 30 minutes, mas marami na sila. Okay? So, the act or the time wherein are required for one cell to divide into two is called generation time or doubling time. Note, your Escherichia coli is fast growing. Within 20 minutes, nagdodoble siya. Okay? Within 20 minutes, nagdodoble siya. Some bacteria, like your Microbacterium, magdodoble lang siya kung after 24 hours. So, kaya mas mahirap ang Microbacterium tuberculosis na patubuin inside the laboratory. Next would be the bacterial growth. So, inside the laboratory, we are actually using broths and media or agar to actually do the growth. So, kapag nag-bacterial culture tayo, malalaman natin na ang bacteria would actually have an optimal time kung kailan lang siya makukulture or mag-grow. Okay? So, example, the bacterial culture or the growth curve. This is the growth curve of a bacteria. So, first would be the lag phase. So, lag phase, dun mo pa lang kakalagay mo pa lang ng bacteria. So, in your first 4 hours, okay, you experience the lag phase. What is the lag phase? In this area, the bacteria is preparing to divide. So, there is a binary fission. Okay? Next would be the log phase. Log as in O. Okay? There would be exponential phase. So, in this case, nag-i-increase yung cell division nila. Okay? In this phase, we are actually giving the patient an antibiotic. Kasi, during the binary fission, diba, nagkakaroon ng, kung mapapansin nyo, may cleavage dito. Okay, may cleavage dun sa binary. Doon, madali nating mai-invade yung bacteria. Okay? Next would be stationary phase. In this phase, ibig sabihin nun, nagamit na niya yung mga nutrients, nagiging limited na. Kasi dumadami na yung bacteria, so pag marami na yung bacteria, mas marami na yung pinapakain. Okay? Kailangan nila ng mas maraming nutrients. So, nagiging stable na lang. Nagiging equal yung pagpoproduce ng bacteria at yung namamatay na bacteria. Ibig sabihin, nagiging equal na lang. Hindi na yung marami na poproduce na bacteria. So, next would be death phase. In this area, dahil nga konti na lang ang nutrition or konti na lang ang ang nutrients na makikita natin o na available, okay, bumabagsak o namamatay din ang bacteria. So, a number of non-viable bacterial cell is exceed number of viable cells. So, mas maraming namamatay kaysa buhay. Okay? Okay, this is just an example of another bacterial growth curve. Okay? So, dito, gumamit sila ng broth. So, sa umpisa, hindi pa masyadong turbid. Nang dumaon, nagiging turbid na. Tapos, sumunod, magkakaroon ng stationary phase. Ibig sabihin, equal yung growth. Okay? At dito sa death phase, konti na lang yung buhay. Okay? So, kung mapapansin nyo, ito yung buhay, ito yung patay. Okay? Dito, sobrang equal lang yung buhay sa kapatay. Dito, almost patay na yung mga bacteria. So, death phase. Next, how we will determine, okay, the cell number in the laboratory. So, we can actually do direct counting under the microscope. So, kukuha tayo ng specimen. Okay, kukuha tayo ng specimen and then i-check natin kung may bacteria. We can actually do this using the gram stain or we can actually do fluorometry. Okay? So dito, yun nga lang, hindi mo madidistinguish kung alin ang patay at alin ang buhay. Mabibilang mo lang kung ilan yung number of cell. Okay? Next, determination of cell number based on the direct plate counting. So, this method counts for viable cell only. So, dito, kapag nilagay natin siya sa plate, ibig sabihin pag tumubo, then it would actually gives us the idea na ganun kadami yung bacteria. So, this would quantify using a unit known as colony forming unit per milliliter. Okay? So, ginagamit din to actually count bacterial cell in the urine sample and then the water sampling. Okay? Kung gusto natin i-test. Next, another way to determine if there is cell or number of bacterial cell, okay, is measuring the density. So, density, paano natin malalaman? Kapag turbid, katulad dito, pag turbid, alam natin na may bacteria. Kapag walang turbidity, then wala siyang bacteria. So, density of bacteria broth culture in log phase can be correlate to CFUM, colony forming unit per ml of the culture. So, ibig sabihin nun, pwede tayong mag-assume na yung kapag nasa broth na, tapos nilagay natin sa plate, similar sila. Okay, next. Note, this density measurement is also used in to standardize inoculum for antibiotic susceptibility testing or antimicrobial susceptibility testing. So, furtherly, we can actually discuss it in finals. Finals pa natin ito madi-discuss. Finals or midterms. Okay? Next. Next would be bacterial metabolism. So, note, ang bacteria na may metabolize din niya, okay, yung mga organic compounds para makapag-synthesize ng bacterial parts. Okay? So, note, yung bacterial metabolism can be used para for diagnostic scheme. Ibig sabihin nun, para makategorize natin kung ano yung bacteria na na-isolate natin. So, it can be used for utilizing various substances as carbon source, production of various substrate, and production of acid or alkaline pH. Note, catabolism is a breakdown of carbohydrates and to produce energy. So, ang bacteria, dahil living thing siya, will do catabolism or metabolism as well. Okay. So, first, ano ba yung ginagawa ng bacteria? It can actually do fermentation. So, it can do an anaerobic process by obligate This is an anaerobic process by obligate and facultative anaerobes. So, ang mga bacteria that would actually undergo fermentation are obligate, anaerobes, and then your facultative anaerobes. Note the electron acceptor are organic compounds. Ano ba yung mga organic compounds? Example are sugars, carbohydrates, your glucose. Note, during the fermentation, katulad ng picture dito, during the fermentation, ang substrate hindi siya completely nare-reduce o nare-release, leading to have an end product and there would be accumulation. So, during the time, after the fermentation, nagkakaroon tayo ng alcohol and carbon dioxide. Okay? Na magkaka-accumulate doon sa medium. Some example ng test na to would be Vogt-Proskauer and then your methyl red. Okay? Fermentation. Okay? Next. Next would be respiration. This is another way on how the bacteria metabolize. By this one, because of the respiration, it needed oxygen. Okay? It needed oxygen. So, it is most efficient energy generating process because the final electron acceptor is your oxygen. Kumpara dun sa fermentation, ang pinaka-final acceptor natin or the electron acceptor natin is the organic compound. For this one, it can be both done by aerobes and anaerobes. For the obligate aerobes, it would actually undergo aerobic respiration, while anaerobes would actually undergo anaerobic respiration using an inorganic compound like your sulfate and the nitrite. Next, we'll be discussing about the three major metabolic pathway. So first is for converting the glucose to pyruvic acid. Okay, an organic compound to a pyruvic acid. Okay? So, ito, we'll be furtherly discussing it also in clinical chemistry. But then again, we'll be aftering this for bacterial purpose. Note, ang katawan natin, lahat ng kinakain natin or lahat ng ginagamit ng bacteria, i-metabolize muna niya. So, ano yung ang glucose, bago siya maging energy, kailangan mag-undergo muna ng metabolic pathway. Okay? One example of this is your Ebden-Mayer-Hoff-Farnas or the glycolytic pathway, the pentose phosphate pathway, and then the Ebner-Dordorov pathway. So, first is your Ebden-Mayer-Hoff-Farnas glycolytic pathway or your glycolysis. Okay? In this part, this is the major pathway for the conversion of your glucose and your pyruvate. Note, dito, papakita ko lang din sa inyo, it can actually done an anaerobic way, does not require oxygen for this part. Note, it needs energy. It needs energy to form energy. Okay? So, kung mapapansin nyo, your ATP, you need to invest 2 ATP before you can actually get 4 ATP. Okay? The glucose is converted to glucose 6-phosphate. And then your glucose 6-phosphate is converted to D-glucose 6-phosphate. And furtherly, using 1 ATP, it would actually convert the D-fructose 6-phosphate to D-fructose 1,6-diphosphate. Using the phosphate, okay, it would undergo further metabolism, and this would help you to actually obtain 4 Note also, it used by many bacteria, including all members of your Enterobacteriaceae. Ang kailangan nilang tandaan dito for the Ebden-Mayer-Hoff-Farnas glycolytic pathway is it actually gives you 4 ATPs. Okay, 4 ATPs and 2 NADH. Okay, next. Okay, this is just an example or animation on how does how does the bacteria would undergo the glycolytic pathway. Okay, so it actually makes 4 ATPs and 2 pyruvates. Next. Okay, so next would be your pentose phosphate pathway. So, kaysa mag-undergo siya ng EMP pathway or the Etten-Meyerhof pathway, it would undergo your pentose phosphate pathway. Note, the difference between this one is the pentose is actually used for nucleotide synthesis. Okay, this is used for nucleotide synthesis. So, your glucose 6-phosphate, kaysa mag-undergo siya ng EMP, it would, the 2-NADP would actually produce a 2-NADPH, forming your ribulose 5P. And it would actually form also ribose. In this pathway, NADPH, okay, it generates NADPH, which provides power to biosynthetic reaction. So, note, it can actually use ATP, pero mas konti na lang. Okay, it actually, compare dun sa isa, dalawang ATP yung kailangan, dito, isang ATP na lang ang ginagamit. So, anong ginagamit natin, anong mga bacteria ang pwedeng undergo ng pentose phosphate pathway? Yung lactobacillus and then your Brucella abortus. Next. Next is your Ettner-Dordorff pathway. So, kesa yung glucose 6-phosphate mako-convert into dun sa pathway which is your EMP and then your PPP or your pentose phosphate pathway, magiging dito sa Ettner-Dordorff pathway na siya gagawin. So, it generates 1 NADPH per molecules of glucose but uses 1 ATP. So, organisms that undergo Ettner-Dordorff pathway are Pseudomonas, Alcaligenes, Enterococcus fecalis, and other bacteria. Next. So, this is your this is a combination of your EMP, PPP, and then your Ettner-Dordorff pathway. So, this pathway is known as your glycolytic pathway or your EMP. Okay, this is your EMP. Okay, this is your EMP. Next is your this pathway. This is your pentose. Sorry, this is your pentose. So, ito pala yung pentose natin. Sorry, hindi pala to EMP. Okay. So, ito pala yung EMP. Okay. So, yan. So, this is a combination of your EMP, PPP, and then your Ettner-Dordorff pathway. Okay? So, ito mas madali intindihin. So, this is your EMP, your Ettner-Dordorff pathway. So, yung glucose 6-phosphate, kesa mag-undergo siya ng EMP, magkakaroon siya ng 6-phosphate gluconate because you'll have your NADPH. Okay? Under the Ettner-Dordorff, you actually use 1 ATP. You produce 1 NADH and 1 NADPH. In the PPP, you would actually undergo biosynthesis of your nucleotide. You have your you invest 1 ATP, okay, or you produce 1 ATP also, and then you have your 2 NADPH. Okay, this is just a summary of ideal prokaryotic aerobic respiration. So, glycolysis, 4 yung napoproduce na ATP, ang nagagamit dalawa yung NADH na napoproduce, and walang FADH2. So, during the synthesis of acetyl-CoA or Krebs cycle, dalawa yung ATP, walang ATP na ginamit, 8 yung NADH. Sa electron transport chain, 34 ang mapoproduce na ATP, pero walang ATP na nagamit. So, total, it would be 40 yung napoproduce. Pero dahil 4 yung 40 yung napoproduce, pero dahil dalawang ATP yung nagamit natin, it would actually have 38. 38 ATPs ang napoproduce. Okay, next would be fermentation pathway, or the anaerobic utilization of your pyruvic acid. So, kung kanina, yung ano natin would be in the aerobic utilization, this is the anaerobic utilization. So, glucose can be converted to ethanol, okay? So, yung mga ginagamit natin as soprophyll alcohol is actually done by the bacteria. Okay? Your hemolactic fermentation, glucose to lactic acid, it is done by Streptococcus and then your Lactobacillus. For the heterolactic, it is a combination of lactic acid and other. Okay? The others can be your carbon dioxide, alcohol, formic acid, and then your acetic acid. Your propionic fermentation is done by the propionic acid. The Propionibacterium acne is one of the bacteria that would actually produce propionic acid. Another fermentation pathway is your mixed acid fermentation, wherein the sugar is fermented into lactic acid, acetic acid, succinic acid, and formic acid. This is done by the Enterobacteriaceae, particularly your Escherichia coli, Shigella, and your Salmonella. Please note, ang isang test to actually assess the mixed acid fermentation is your methyl red. Okay, methyl red. Okay, to assess the mixed acid fermentation. So, your butane diol fermentation, the end product is acetone and the 2,3-butane diol. So, one example of this would be your Klebsiella species, Enterobacter, and Serratia species. So, one test that would actually assess the butane diol fermentation is your Vos-Proskauer. Okay? Next would be the butyric fermentation. So, the end product would be butyric acid. Some of the organisms that produce butyric acid as an end product during the fermentation are your Clostridium, Fusobacterium, and Eubacterium species. Okay? This is coming from Tortora. This actually assessed that your glucose is converted to pyruvic acid during the fermentation. During the fermentation, it is not all are oxidized or not all are consumed. So, there is a product like your Propionibacterium. It has your propionic acid and your carbon dioxide. Usually, the fermentation product would be Swiss cheese. Okay? If it is Aspergillus, Lactobacillus, Streptococcus, it would produce lactic acid. It can actually produce soy sauce, cheddar cheese. For the Saccharomyces, it is can produce ethanol and carbon dioxide, and it would actually produce wines, beers. Okay? Clostridium, it can produce acetone, isopropanol, or the rubbing alcohol. Okay? So, it would, in this industrial, You can actually produce nail polish remover, rubbing alcohol, okay? And then, your Escherichia coli and Acetobacter would actually produce acetic acid or the vinegar. Okay? Next would be aerobic utilization of pyruvate or the oxidation. Okay? This is done by Krebs cycle. Okay? Krebs cycle or tricarboxylic acid cycle. So this is an forming an ATP. Like I told you, it actually forms almost 34 to 38 ATPs. So these cycles produce citric acid and evolution of your carbon dioxide. So this is your Krebs cycle or tricarboxyl acid. Next is, how does carbohydrate utilize, how does bacteria utilize carbohydrates in lactose fermentation? Kanina kasi, during the fermentation ng glucose, most of the organism would utilize glucose. But for now, we'll be discussing about the how does the bacteria would utilize or ferment lactose and or other carbohydrates. Note, a carbohydrate can be a monosaccharide or disaccharide. Or it can be a polysaccharide. So, kung ano yung mga kinakain natin, okay, or the starch, it is a polysaccharide. Okay? Your glucose is a disaccharide. A lactose is, note, it is a disaccharide. So, a bacteria can actually utilize or ferment lactose. So, fermentation of sugar is usually detected by acid reduction or change in the color resulting from pH indicator present in the culture medium. Note, the bacteria can actually utilize lactose. Note, lactose is a disaccharide consisting of a glucose and a galactose, linking by a galactoside bond. Okay? So, bacteria can be a lactose fermenter, okay, if it has the two enzymes. What are the two enzymes? The two enzymes is your beta-galactoside permease, the beta-galactoside permease. Permease. Okay? So, this would help, the beta-galactoside permease would help the lactose, okay, it will help the transport of your lactose across the cell wall para makapasok siya dun sa bacterial cell. So, next, the lactose, kapag nasa would require enzyme which is the beta-galactosidase. So, this would break the bond, it would break the bond between the glucose and the galactose. So, it will break the galactoside bond. Okay? So, the galactosidase would break the glucose and the galactose. So, yung lactose na disaccharide, magiging monosaccharide siya. Okay? So, it would expel the galactose kasi hindi naman kailangan ng bacterial cell, and the glucose would undergo glycolysis. Okay? Or would undergo fermentation as well. Okay? So, that is how the lactose is ferment. Okay? So, note, sino ba yung mga lactose fermenter? It is your Enterobacteriaceae, Escherichia coli, Klebsiella, okay? Enterobacter are examples of lactose fermenters. Okay? It can actually ferment lactose. Okay? Please note the two enzymes that needed for the lactose fermentation. It is your beta-galactoside permease and then your beta-galactosidase. Thank you, and I hope you actually learn about bacterial metabolism.